Exam question, we're going to have a look at using this trig identity from year 1 maths to solve this. So how do we go about doing this? Well, you might notice this kind of looks like a quadratic, but we can't deal with it as a quadratic because this isn't in the cos squared format. So we can rearrange this equation to make sine squared the subject by taking away cos squared from both sides, and we can say that sine squared is equal to 1 minus cos squared. You can include the theta here and here, but I just didn't include it because there's not much space. From there, you can replace 3 sine squared theta, because you can say that, well, 3 times everything on the right hand side, 1 minus cos squared theta, which would just, you can just expand out the brackets here. That would be 3 take away 3 cos squared theta. All of that is equal to what's on the other side of the equation, 2 cos theta. It almost looks like a quadratic now, but in order to solve it, we need one side to equal 0. So let's take everything to the right hand side, just so this number before the cos squared is positive. That would mean we're adding 3 cos squared first to both sides. And then this 2 cos theta is already positive. And then we can just make it equal to 3 on the left side. But just to make it easier, we can take away 3 from both sides too. And then say all that's equal to 0. Now what you want to do is you want to replace cos with a singular letter. Unless you're able to factorize it like this already, that's completely fine. Once you replace y with cos theta, you can then say cos squared is then just y squared. So then we have 3y squared plus 2y plus 3 minus 3 equals 0. And now this is a familiar format for everyone to factorize in. But like I mentioned, you can factorize from here if you'd like. So you take the first and last number, minus 9. The factors are that also add to give positive 2. Well, actually, there aren't any here. So that means we have to use a quadratic formula. So I'm going to quickly do that on my calculator. So just spare me one moment. Must be plus or minus square root of... If you like, you can open up the quadratic formula in a different tab. You can have a go yourself. B squared minus 4ac all over 2a. Okay, that gives 0.721. Or the other solution is... Okay, I'm going to write both solutions out. So 0.721 is what I got when I put plus on the quadratic formula. And then when I use the minus sign, I got minus 1.39. Here is where we replace the cos theta again with y. And we say that cos theta could equal 0.721, or it could equal minus 1.39. You might have spotted something here, and if you did, that's brilliant, which is that cos theta has a maximum value of 1 and a minimum of minus 1. So this here won't have any solutions because it doesn't go below minus 1. So it doesn't make sense for this to have solutions. This is in the range of minus 1 to positive 1, so it does have solutions. And when you do the inverse cos of everything on the right side, 0.721, on the calculator, you'll get the value of... So I'm just going to quickly do that. Bear with me one moment. 0.721, 43.9 degrees. And there's one more difficult part of this question, which is realizing that it wants a solution between 180 and 360. Now, if you plot the cos graph very briefly, it doesn't need to be accurate at all. Sorry, I'm awful at drawing. Like I mentioned, it has a maximum of 1, minimum of minus 1, but you just want to plot like the key coordinates, like 180, 90, 270. So when it's equal to 0.721, that's like here. It's equal at this point and also at this point here. Because of the reflective nature of the cos graph, if we do 360 take away this value, we're going to get the other value of cos. So I'm going to do this in a different color, just to separate it a little bit. But if you do 360 minus 43.9, you get the other value, which actually is in between this range. So let's do that one. 316 degrees. And that's your final answer actually. That's the only solution of this whole equation in between 180 and 360. Apologies for the graph, it's horrible, but hopefully you get the idea that if you have one solution of cos, you can get the other one by doing 360, take away that one solution. Thanks for watching, and if you have any questions, just let me know. I'm still getting used to whiteboards, so sorry for the handwriting. And yeah, if you have any tutoring inquiries, just hit up my email, it's in the description. Otherwise, subscribe. I'll see you tomorrow with a new video.